Okay, let's look at this question here. So we're told to find A, B, C, D. So the first thing is to write down the value of D. Shouldn't be an issue. You know that the vertical asymptote, okay, you can just compare, right? This vertical asymptote is x equals to 2. So this guy, same thing. You can just write the vertical asymptote here. X plus D equals to 0. So this will be x equals to minus D. So you compare with the vertical asymptote given to us. We know that D equals to minus 2. Okay, not an issue. So just write down. So that after that, we are told to state the value of A. I think we can do a long division for this case here because we were given the oblique asymptote as minus 2x plus 3, the OA. Okay, then we can compare the A later. So we're just gonna do a long division. Okay, then this case here, multiply AX to give us AX squared. Then minus off, we'll get B plus 2AX. Then lastly, we'll just plus B plus 2A. Okay, this is B plus 2A. X minus 2b plus 2a. That's about it. So this will be c plus 2b plus 2a. Okay, so you compare the just write down in proper fraction. You know that this is the oblique asymptote here. Okay, this is oblique asymptote. So OA is y equals to ax plus b plus 2a. Then we compare this with our minus 3x plus 2. Minus 2x plus 3. So by comparing, we know a is minus 2, not an issue. After which we know b plus 2a equals to 3. Okay, then this will be b equals to, so minus 2 plus minus 2 equals to 3. There you go. A equals to minus 2 and b equals to 7 shown. So for C, we are given that the stationary point is where x equals to 0, x equals, so dy dx when at x equals to 1 is 0. Okay, so I'm just going to use that. Okay, just use obviously put in a, b, and d inside, then we'll just try. So what we're going to do is dy dx using quotient rule. V square v du dx, right? This is u, this is v. So du dx is minus 4x plus 7 minus u dv dx, which is 1. Okay, 1. There you go. So you can get that answer. Obviously, you don't need to expand everything because we are given the boundary condition, right? So when x equals to 1 is 0, so we just sub 1 inside the expression. So 1, 1, 1, 1, 1. Okay, so there'll be negative 1. 1 will be, this will be 3. Minus 2 plus 7 plus c multiplied by 1 over minus 1 square equals to 0. Okay, there you go. So I'll get is c is minus 8. Great. And what we're going to do is we're asked to find the other x coordinate. I'm not sure if this is 1 or this is 1. Okay, so if this is 1, then we need to find the x coordinate here. If this is 1, then we need to find x coordinate, basically the other x coordinate. So we just need to the other x coordinate of the stationary point, because there are two stationary points here, right? So just substitute all the values into this guy here, the dy dx here. So I'm going to substitute the c in. Okay, so at stationary value, dy dx is 0. So numerator I expand and let it be 0. So this one I expand it out. Okay, so then I'm going to solve this guy. So from here, just a basic manipulation. So if x equals to 1 or x equals to 3, so we reject this. This is not available because this is the previous one. So we know that this is 1 and this is 3. Okay, so the x coordinate of the other stationary point. Done. The next part should be copy the above sketch, and by drawing another suitable curve on the same diagram, show that this equation has exactly 2 roots. Now, I think the first thing is to just use a GC, then sketch it. I would always suggest students to just put into the find and verify that your answer is correct before you move on. Okay, so just use a GC. So from here, I'm going to just put in all my values. So this guy, here. Then we have A. A was A, B, C, and D. So negative 2x squared plus 7x minus 8. Then this will be x minus 2. Okay. Then when I'm going to do this, really, I'm just going to key in the calculator. Then I'm going to zoom standard. This is the graph I'm looking at. Of course, put your OA in. OA will be 3 minus 2x, right? Just 3 minus 2x. So put it into GC. 3 minus 2x. Okay, graph it. There you go. This is the shape here. Okay. Then verify that your max min point is all the same. You're using GC. So from here, what I get is because they asked us to copy the graph. So just this is minus 2, then this is y goes to 3 minus 2x. This guy, the max point and the mean point here, 1. Okay. So this is 1. You want to find the y value, you can just use GC or you can just substitute it in. Just trace 1. There will be 1, 3. Then whereas for the other one is trace number 3, which is 3 comma negative 5. Okay, so that's it. Then check this value here. This intercept will be 3, 0, will be 0, 4. So we are told to show that there are two solutions here. So the main thing is look at the coefficient here. This is negative 2, negative 7 plus 8. So basically it's different, right? This case here. What I'm going to do is I'm going to move the negative to the other side. Okay, we see what equation it gets. So this will be x minus 2 x4 minus 7x cubed minus 8x squared. Okay, then basically I got the coefficient already, but I need this to be x squared, x and a constant. So here we could just divide by x squared, right? Divide by x squared. Okay, when I divide by x squared, I would get the graph that I'm looking at. So this guy will be x minus 2 over x squared equals to minus 2x squared minus 7 x minus 8. Okay, there you go. Obviously you need to divide by x over 2 because so basically just divide by x over 2 to get the original curve, right? So this guy, same thing, x minus 2, sorry, it's x minus 2. This is 1 over x squared equals to minus 2x squared minus x minus 8 over x minus. So you can see that this is your y1, which is the curve, and this is your y2, which is not very hard to see the graph, right? This one. So you need to find the number of intersection between the curve and this shape of the graph shouldn't be an issue. This one is just our normal graph that we learned in secondary school, which is this guy here. 1 over x squared is this guy, right? Okay. You can even draw it on your GC. So you just draw this out. 1 over x squared. Okay. So this is a shape here. So you can see very clearly they have two what do you call it? Two intersection point. Okay. That's it. They want you to show that there are two intersection points. So from the GC you can see that. Okay. So there you go. You able to show. You just draw the curve out and show that intersect twice. Then that's why you have two real solutions. Okay. So that's how I do this question here proficiently.